All right, so Kevin, tell me about this fabulous V12, because I posted some pictures of this on a Bonneville land speed racing forum, and it really sparked up a lot of interest. And
well, this it started out, you know, a few years ago. Pete wanted to build a V12, and we started out with some GM heads, an inline 6 GM 4-valve per cylinder. Pete wants to do everything with 4-valve per cylinder, so we started out with originally with the GM, and then when the fire came, took out his house, all that burned up. So we were talking a couple of years ago about building another V12, and so he got some Jaguar heads, and we were thinking about making out of that. So that's when we came up with, we had a couple of these Aurora heads here, which are 4-valve per cylinders, and what we did is we cut one cylinder off of each head to make the 4-valve cylinder heads, and these flow real good air, and this really flows a lot per square inch of valve area.
So here's Pete. Now, Pete, how did we acquire these Aurora heads?
Well, Tony Pereira from San Jose, a Bonneville racer, had a Mickey Thompson cylinder head, a 2-valve Hemi twin cam head for Chevrolet that Mickey Thompson built.
Okay.
Unmachined, so we machined it. We put it all together with belts and like we do.
Okay.
And he bought all of Roush and AJ Foyt's IRL Aurora parts, Indy parts.
Okay.
So he gave us the 4 heads, cut one cylinder off each head and welded them together. And made
So this is, okay, so can you explain how you did this? I'm going to come in up close. You can show us kind of where you cut it and how you scabbed it together.
Well, we cut one cylinder off the head. There, this makes a 3-cylinder head, right?
Okay. Yep, you can see the
Right.
intake port and exhaust port.
We bolted a plate on this end for the water and oil
Okay.
to keep it from leaking, and then we welded them back to back. This welded to the
So
back.
there's actually like a little void in here.
Well, you can
That's
see
the water jet.
You can see
The
the
water
spacing here. This spacing is 4 inch. This is about 5.5.
And that's where the actual weld, where they're both
weld-
welded together, and I see you machined it.
Right.
Okay.
We did it back to back so we didn't have to fight the oil or the water. Because if you weld them this side, you got
You got to close all this up.
Oh,
But
you
this
gotta
is
close
dead
it.
space here. There's already sealed,
Right.
So you weld them back to back.
right. And then we bolted them on a plate, machined them
And
flat.
we put a shaft through the cam boards to keep them in line.
Keep it as straight as we could.
When you welded it.
Yeah, and then when we made the cams, we made them 30 thousandths bigger than stock, so that you had something to clean up when you board it, line board it.
There's 48 valves, 48 buckets. These are what they call buckets. They sit right on top of the spring. And then we use the IRL throttle bodies. They come in 4s. They sit on here. I don't know where they are now, but we cut one off each set, and made these adapters to accept the, because this is 60 degrees, so it's a lot tighter than the 90 degree that the engine.
Okay. Yeah, I can see that on the block.
So
Absolutely.
then this adapter had to be a different angle than the Oldsmobile. These are Corolla rods that came from Tony. We had to buy the CP pistons from CP because we were a little overboard, different dimensions than the Oldsmobile was. We made our own valve cover. In fact, we made almost everything on this engine. This is, we made a billet girdle, which is the bottom half of the block. And then this bolt, this is the oil paint, and it's got 6 individual ports for the oil pump, for the dry sump pump. And this pumps up to the cam and rods and pistons and all that stuff. It's a belt driven, just like NASCAR or any other high performance engine.
So can you tell us a little bit more about the block? I know we just got into it. You said it's 60 degrees, right?
60 degree. It's
Okay.
There's 4 pieces here that we actually made. There's this bottom part, this bottom 2.5 inches, which is the girdle, which holds the crank down. Then there's the middle section, which is right here, this part,
Okay.
which it looks like a doghouse. The crank spins in the middle, and it's just, and then we took two pieces of this stuff, the length of the engine. This is for V8, but it's 4 by 6 by ½ inch wall,
Okay.
and that gets bolted onto the. That gets welded to the middle section. Gets welded to that section there, and then this is bored for the sleeves.
And the sleeves are set in it. Okay.
So then the water,
That's
everything
the
else
jacket.
is everything else is water. These are wet sleeves. They get, this gets bored, this gets pushed
Sleeves
in
get
there.
inserted. Okay.
So that made up the block. And we also, we had to make the end, and because the cylinders are offset a little bit, this goes in here.
Oh, I got it now. So now it's coming together. See?
And then the
Now-
other one is here.
here, and now you've got your 60-degree block.
Yeah.
The girdle is the caps for the crank.
And Kevin, who was the manufacturer of the crankshaft? Who was able
The
to build
scat
that?
crank.
Scat. So was this a pretty odd and unique request to have made?
Yeah, well, like I say, it took them a couple of years to make it. It was not something they have on the shelf. So,
So here you can see all the welds, right? Or it was
Yeah.
all put
Yeah.
together.
There's a passage in here for the oil.
on this side.
And these are return oil from the head, run return. This is water. We pump water in the middle. No, we don't. Just in the ends, we pump water in.
So it comes out the middle of the heads, the block to the heads.
Yeah, it goes in here, comes out here, into the head,
And out on the ends of the heads.
out each end of the head.
Now, last month this was run at Bonneville. I know it ran lean, it had a couple issues, but it did run a 278, right?
On a
A
276
4-mile
record.
run.
Yeah, 4 mile.
And it was, I believe it was, what, 920 horsepower when you ran it on the dyno at...
Right. It's a 6 liter, but we're racing small block Chevys in 4 configuration. This would be the end, the bell housing end, and the 2 cylinders. The part we made, or that Kevin made, is the center section, which looks like it's a doghouse.
The doghouse.
That goes in here, and it gets all welded here, here, everywhere.
And then the journals are notched in there for the
Right.
crank.
Right. They're part of the middle section.
Are they different segments that you drop in?
No, it's one
Or-
piece.
One piece.
Right. We don't have one.
Okay.
Well, it's there.
It's there.
And then we heat treated it, bring it back down to T6,
Okay.
and then we machined it, and then it was a 3-year project, but it paid off. Right.
Went down. So tell us what happened there.
Well, the distance here, I don't know if it'll pick it up, but from the top ring to the exhaust valve notch, it's only about 60 thousandths there, and it got hot because it was running lean.
Sure, you'll see a better kind of this pocket here. Actually, the other piston showed it better.
We had
But
tested.
it's actually it gets thinner than this.
Kevin, what do we have for fuel injection on this, or what's our fuel injection?
This was the stock Aurora fuel injection, and again we cut one barrel valve off to get it so that, or one valve, one cylinder's worth off.
Where it called?
Yeah.
This
So
was
that
for
this is made
original.
out of magnesium. It was made by Kinsler for the Aurora motors, and then the problem with this is now because this is 60 degree, these are a lot closer to each other, so they actually fit on the head like this, and so this actually holds our intake runners of the radius entry into the engine.
Okay.
These are for the injectors.
Injectors are in here.
Yes.
Right.
And this is electronic or mechanical fuel injector?
Electronic.
Electronic. Okay. Pulse width modulated. All right.
It's Adaptronics.
Adaptronics.
Australia.
Yes, made in Australia.
Wonderful. Beautiful piece of art.